So here we go. The Industrial Revolution for 1750 to 1850. You have a crash course in world history video on this too. It'll be a little faster. It'll be certainly funnier than what I'm about to do. But now here we are with the Industrial Revolution. Finally, for those of you who have been providing definitions of science and technology, and that technology is applied science, the Industrial Revolution is our best example of exactly that happening. So the idea of science being applied to society, science being applied to the manufacturing, to technology that we already had, and essentially science applied to existing technology is going to speed it up faster and faster. Now, you know this in the world in which you live, that science applied to technology, particularly technology associated with communication, whether it and entertainment, right, it just speeds up constantly in your own lifetime. So the same is going on here in the Industrial Revolution. It's a little slower perhaps than we're used to, but for the people living in the time, significant change was underway, and they knew it. They were experiencing it. In particular, in the Industrial Revolution, we're going to see changes in sources of power. We're going to have new sources of power. We'd already used coal to heat dwellings in addition to using wood, but now we're going to see coal and steam replace wind power and water power. Wind power for sailing, wind power for turning windmills, water power for for transportation, right? For moving people along on rivers, but also water power for moving water wheels that would grind grain for us. So we're going to replace that wind power and that water power with coal and steam. We're going to start to see some labor-saving machines being developed, and these labor-saving machines will replace both human power and animal power. One of the ways that we're going to see this start to happen is in craftsmanship, in manufacturing. And we're going to see the world go from small workshops, small craftsmanship, if you will, to and cottage industries. So workshops, cottage industries, basically, we'll talk a little bit more about what cottage industries are. And we're going to move to large factories. We're going to start to stress quantity over quality, right? So quantity of goods produced versus the quality and the time that it takes to produce things in a slower fashion. So again, we're speeding up processes with these new sources of power. Finally, human labor is going to be organized differently. Very much. If you'll remember way back at the beginning of this class, a whole couple of 3 weeks ago, we talked about the hydrology thesis, right? The hydrology hypothesis. This idea that irrigation in early societies made it possible for places where water was at either too much water or too little water to allow for the development of civilization. Many of you noted in your quizzes, and I remarked on many of your answers there, that not only did it allow for agriculture, but it changed the way human society developed. The Industrial Revolution, with these new sources of power, coal, steam, are going to replace water and wind, are going to mean that human labor, just as in the beginning of this class, is going to start to be organized differently. And when human labor gets organized differently, people are going to see in their daily lives significant changes, again, brought by science and technology. Our story of the Industrial Revolution begins in England. England, you know, is an island, and it is an island of natural resources. There is a great supply of timber, there's a great supply of coal, iron, and as we move into the 19th century, a growing supply of labor. As I noted earlier, the origins of the Industrial Revolution seem to be in England. It's going to take place all over the world, but first in England. New technology in agriculture had created an agricultural surplus. That means that the food supply in England as we move into the 1750s was greater than ever. People did not have to spend the majority of their labor or their income in procuring food. And this was a significant change. Again, new agricultural technology allowed agricultural output to increase. So this population growth equals a potential labor pool. Something very important for the Industrial Revolution. Other things to consider. Economics and statecraft. Banking in London was unique in most of Europe. It allowed for check writing. It allowed for paper money. This is a new development as we move into the late 18th and the early 19th century. The idea that you don't have to carry a suitcase full of cash with you everywhere to make transactions. You could actually sign a piece of paper guaranteeing that you had the money in a bank somewhere and you were transferring it to a seller, transferring it to a purchaser, right? So this is extraordinary in London, and again, happened no other place at the time. The other thing that's going on at the time is that there's limited liability for corporations. Now you might be thinking, what? She's doing business law. Yes, indeed, we are. In England, before any place else, we're going to see that state law, governmental law, allowed for groups of people to get together to engage in a venture. This is venture capitalism. Engage in a venture of some sort that might have had some kind of risk. And in England, you were allowed to spread that risk, spread that liability amongst a whole group of people. If you were in any other country in Europe and you tried to put together a risky venture with, say, 10 investors, if the thing went belly up, the government or the bank or whoever had lent you the money would come after each individual person, and each individual person was responsible for the entire debt. In England, each individual person is limited in the amount of liability that he or she owes if a venture fails. So limited liability corporations allowed for folks to take more risk. Add to that, and some of you know a little bit of the history of Europe, but you may remember that in 1776 we have a revolution in the Americas. In 1789 we have a revolution in France. In the 1700s, yes, indeed, the revolution in America did affect Britain, but locally, stably, in the state, a very stable government. England has an empire in the 18th century. We mentioned the U.S. as a group that's rebelling against them. Empire means for England that there are raw materials in the world. Cotton from North America, cotton also from India. And also, there are ready markets. You have colonists and subjects living in the colonies, both in North America and, say, India and other places around the world. They are in Latin America. They are in Africa, Asia. And so the empire was set up to retrieve raw materials from its colonies, bring those raw materials home, manufacture them into goods that could be sold back to their colonies. England has a great navy. So this navy is helpful for protecting your merchants who are shipping goods around the world. It's great for maintaining that empire that gives you your raw materials and your ready markets. England also has a good merchant marine. So again, two naval groups, if you will, that can help get goods around the planet. So good economics, good banking, limited liability, stable government, an empire, a great navy, supported by a merchant marine. This map I like just because it's an older map and it represents how at the end of our so-called Industrial Revolution, at the end of this 100-year period, the empire that the British have, it's all the areas that are in pink, right? So by now, by 1886, the Americans have rebelled, and so Britain still holds Canada here in North America. It has very limited holdings in Latin America and in the Caribbean, Africa, India, Australia. Britain had holdings up in Asia, but some of those are now no longer going concerns. One of the things that's a little harder to quantify is this concept of an entrepreneurial spirit. And this is another element of the Industrial Revolution in England. There were many failures and successes in trying to get ideas off the ground. This is also the development of capitalism in the modern sense, yeah? So we have examples like this fellow named Smiles, another named Wedgwood, and both of them are great examples of the entrepreneur in England who honestly would invest all of his wealth into an idea. The idea might succeed, and yay, we've made some cash, or we have a product that has a market, and we're going to make some money on this. Oftentimes they would fail. We have stories of Wedgwood. You may know the name Wedgwood, very famous for the pottery he did for the China. We call it China today. His pottery works, his kilns blew up frequently. So he had lots of challenges developing products. So this idea of being able to handle failures in an effort to wait for those successes that come. This is a big entrepreneurial spirit in England. Mineral resources we may have talked about already. England is a place where coal and iron are just part of the natural landscape, part of the natural resources. And then also there's good communications in England. England itself is a small country. You're never really more than 70 miles from the coast, no matter where you are. And England has good rivers for shipping internally, and England has what's called the King's Highway. We might call it our federal highway system today, but in the 18th century, in the 1700s, England has a highway system that is supported, maintained, and regulated by their monarchy. So, great entrepreneurial spirit, good mineral resources, and a small country that allows lots of exchange of ideas, information, goods, and peoples. We talked earlier about how we're going to see it going from a cottage industry in England or the small workshop in England to the factory system. And this image is of the cottage industry. The cottage industry was the idea that farmers working away, working the soil, could on occasion be engaged in craftsmanship. This particular image is of textile manufacturing. And what we understand was that an enterprising entrepreneur would go to one family perhaps and ask them to take raw wool and spin it into yarn. And that's all they would ask them to do. So in your spare time, could you do this? At the end of a month, give me what you've got done. So and he would pay them or trade something for that labor. He would then go to another cottage, another household, take that yarn and ask them to then weave it into fabric. The next step would be to take the fabric to another household and have them tailor that into whatever goods you were hoping to make. This, as you might imagine, was rather slow, was rather time-consuming, and meant that the entrepreneur was on the road all the time. And as we said before, England had extraordinary resources and extraordinary markets. It turns out that these kinds of entrepreneurs, particularly in the textile business, could always sell more than they were able to produce with the cottage industry system. So they were looking for a faster way to produce more goods because they just knew they could sell even more. One of the ways they hoped to make faster, right, the cottage industry was through new power forms. And this is the time, as we've suggested, that science is going to help us apply some of the theories from science to technology. And we're going to move from water power to steam power. So the first factories, if we can even call them that, factory is just a Latin word for place to work, were near rivers. And so these entrepreneurs became inventors, and they invented things that made weaving and spinning faster. So you'll hear about the flying shuttle, the spinning jenny, power looms. And these were machines that people had to manage, but they could produce far more materials, far more yarn, far more cloth, because they were actually powered by steam. Well, the first one's by the rivers, powered by water. A water wheel would turn these things somehow, and they could run 24/7. So long as the river was running, the loom could be running. In 1814, there were 2,400 power looms run this way. In 1820, 14,000. By 1833, 100,000. This is amazing, right? How quickly we're going to looms that are run by water power and then eventually steam power. Yeah, it just keeps going. So the markets were just extraordinary, and enterprising entrepreneurs, inventors tried to figure out ways to go from that cottage industry to a factory system. And again, first we start with water, and then we move to steam. When you move to a steam-powered factory, you don't have to be by the river anymore. And that's one of the benefits of moving to steam, is that you can place your factory somewhere where there are a lot of people who want to work. And when we start to switch to steam-powered factories, one of the things that these entrepreneurs and these manufacturers realize is that they can locate their factories in cities, big cities, where more people are located. So this image is meant to be a steam-powered textile factory, and what you have up here are these big turbines, if you will. Here's a nice long pipe, and you've got this turbine that's turning these straps, probably these leather straps, that turn these wheels down here, right? And that turn eventually these looms. Now you have these women working the looms. They just want to make sure that they stay in line and they don't mess up. But so you still have people working them, but they're producing far more material than they ever could have just at the loom in their house. So how do we get the steam power? Your video on the crash course on the Industrial Revolution, we'll talk a little bit about James Watt, and there is this story, perhaps, of him waiting for his tea and watching a kettle come to the boil, and as the kettle came to the boil, the lid wasn't on quite right, and as the steam rose, the lid started popping up and down, and he realized this understanding that you could use steam, the power of steam. James Watt is from Scotland, and in particular, he had been given a problem. He was working some coal mines in Scotland as an engineer, and he was told, look, coal mines are underground. When it rains, which it often does in Scotland and in England, it's a very rainy place, water runs down into the mines, collects in the mines. We've got to pump that water out before we can continue to work. How can we pump it out more efficiently? Faster. So we've been talking about textiles. How can we go faster? Now steam. Coal mining, how can we do it? How can we do this operation faster? A Frenchman had developed an engine, a pump, called the Newcomen engine, and it was a steam engine, and the idea was you heat up some water, the water produces steam, the steam will drive a piston, and the piston will drive a pump, and the water will come out of the mine. What Watt did was to modify this machine to make it more efficient, and that's why he's given credit for the steam engine instead of Newcomen. Watt demonstrated that about 3/4 of the thermal energy of the steam was being consumed in heating the engine cylinder on every cycle. Right? So you have to have a cycle in order to, every time you want to move your gears, right, to run your pump, it runs through a cycle for every time. So he demonstrated that the thermal energy of the steam was being consumed too much in heating the engine cylinder. Basically, the energy was wasted because later in the cycle, cold water was injected into the cylinder to condense the steam to reduce its pressure. So you were heating it up to a level to make the machine work, but then you wanted to cool it down in order to reduce the pressure in the cylinder. Thus, by repeatedly heating and cooling the cylinder, the engine wasted most of its thermal energy, because you heat it up, then you cool it down, then you have to heat it up again. So rather than converting most of the heat to mechanical energy, we were losing it. So a very inefficient machine, if that makes sense, right? We're heating it and then cooling it, heating it and cooling it. So he figured out how to modify it to hang on to that thermal energy that was otherwise being lost. So what are the next steps? Can we apply the steam engine to vehicles that transport things other than water and coal? Because what started happening is that we're using that steam to pump water, transport water, and then the next thing that they did was to take his little engine that he created and say, well, if you can use it to turn wheels that make pistons, basically you heat up the heat, it drives the piston turns a wheel that runs the pump. If we can do that, can we also do something similar to make wheels turn that will actually pull coal on a little cart out of the coal mine, right? And he said, sure, why not? So we can create these little carts coming out of coal mines. And then also we're going to take the same steam and apply it to the machinery and textile mills, as we've already seen. Can we apply it to transportation of something other than coal? And we have, in the Industrial Revolution, the development of the rocket. The rocket is the first locomotive. The rocket is the first train. Now, watch out. This sucker, when it was first developed, first built, could go 16 miles an hour. Now, you might be thinking, whoa, step back, whoa, Nelly, 16 miles an hour. But 16 miles an hour, you got to remember that most people could cover, if they needed to walk a distance, they could walk 20 miles in a day, right? So from sunup to sundown, say, before you got too tired, 20 miles in a day you could cover. And that was about average. Now we're going to go 16 miles in an hour. This is fast. This is amazing. It won't take long before the speed of that train goes from 16 miles an hour to 50 miles an hour. And that's impressive. Very fast. By 1850, there are 6,000 miles of train track in England. And this is going to change transportation. This is going to change business phenomenally. Again, how can we do things faster? That's the Industrial Revolution all around. Here's our train. Here's an example of one of the first locomotives. Now, you're right. It takes a lot of coal to shovel into this machine to get the steam necessary to drive the pistons that will turn the wheels, etc. Right? So it is perhaps not the most energy efficient machine ever created, but at the time it was a wonder. Other elements, speaking of wonders, we get to the Crystal Palace, 1851. There is an international exposition in London inviting all the world to come to London to see the fabulous technology, the fabulous new developments and discoveries in the Industrial Revolution. And they took a building and built it specifically for this expedition, and they made it as most they could almost entirely out of glass. So it's steel. We're getting steel for the first time. Steel and glass. Not only that, I don't know if you can tell, but right here, there's a big tree in the center. And they completely built the building around the tree. And the point here was, and if you're remembering our first discussions about the role of nature in technology, we are encasing a tree in this beautiful building built by human hands. We are actually taking over, sheltering nature. Nature's inside. This is an interior, and you can see all the various flags from all the various countries of the world coming to participate in this great expo, this International Technology Expo. So the Industrial Revolution, moving faster, faster and faster. What can we do? How can we move people faster, goods faster? How can we manufacture them faster? What you might, of course, understand is even though we've got this fabulous Crystal Palace and beautiful things are happening, McClellan and Dorn will tell you one of the drawbacks of this is that we are starting to move more and more people into cities, into factory work, And the cities really aren't ready for it. The cities aren't ready. There are sewage problems, there are lighting problems, there are housing problems. What's fascinating to me as well is that when it comes to local communities, government officials are arguing that there aren't enough churches in London to support the huge population that now lives there. People move so quickly from the countryside to the city that the small churches in London that used to be just fine in the 1600s no longer were enough to support the huge numbers of people now living in the cities. In about the beginning of 1800, London will be a city of over 1 million. And that's pretty impressive. It will be the largest city in the world at the time, as I understand it. Certainly the largest in Europe. And they don't have public water supply. They don't have a public education system. They don't have electricity with lighting in the streets. They don't have even gas lighting in the streets at this point. So no police force. So it's a really fast system, and it's going to take most of the 19th century for England to catch up to all the things that they need to be doing with regard to the kinds of changes that have come so quickly. So one of the things that happens as we move into the 1800s, you've already done it. You've written about Mary Shelley, or you're looking at this before you write about Mary Shelley, and we start to see movements in art and literature, wondering if we've moved too far too fast, if we've gone too far too fast. And we see this in Shelley's writing, but we also see it in art. And so I just wanted to give you a few examples of some of the art that we see here. This is a beautiful piece by Caspar, and this fellow is looking into the future. What's coming next? It's a little hazy. It's a little foggy. What's over the next horizon? It's kind of romantic because it's you don't see his face, but he's obviously sort of a climber, an adventurer, a hiker. He's out in nature, but he's also looking to the future. What's next? It's a little scary. It's a little beautiful. This image from Goya out of Spain relates to some of the political revolutions that are going on at the time. But again, art that represents maybe violence, maybe sort of a passion for bringing together sympathy for these folks who are being shot. Right? These are revolutionaries, to be sure, but they're peasants. They're farmers. Their lives have changed so dramatically. Jackson Turner, also a great British artist of the day. And what you have here is a steam ship. I don't know if you can see the flames that he's representing. He's a very interesting artist in that you also have this big sailing ship in the background, right? So a big sailing ship here, a steamship here, and one seems to be pulling the other like a tugboat into port, or racing the other like into port. And you see this beautiful sunset. But this fellow in the background, this ship in the background, almost looking as like it's a ghost ship of some sort. You also get mythological themes, romantic themes, and in this one, a knight, probably Sir Gawain, who's put away his armor for a tryst with his lady love. This also could be Odysseus and Penelope with this great shield here. This could also be any number of great heroic leaders. But what you should be noticing is all of the nature back here. Here's this fellow kind of spying on them. You see the beautiful images of nature, the greenery. You see the river, this very beautiful river, not polluted by industry. And so we get in art a tradition of trying to go back to nature, trying to go back to something more romantic. This image, very common in this is the pre-Raphaelites. This is this idea of the female form sort of floating in this beautiful river that we're kind of one with nature. You get this beautiful image in the background, and this woman sort of just being part of nature, floating along in this beautiful gown. A very common image, very popular image, that again recalls the beauty of nature. When we're living in these amazing cities, these extraordinary times, and they're so fast, wouldn't it be nice just to chill out, slow down, commune with nature?